We'll wrap up sulfur talking about sulfur management. There's, not surprisingly, not a lot of different types of sulfur fertilizers out there. Um, and thinking about what are the sources that we have to deal with or have to work with in terms of um, if we need to apply sulfur or fertilize with sulfur, what are our options? Okay, and so this is again a big kind of nasty table, and we can see that some of the sulfur sources uh, exist. Very few of them actually exist by themselves, but some of them might exist with nitrogen or with calcium, with iron, with N, P, or even K. So there's a lot of things out there. I'm going to talk really about the most common ones. And that's this list right here: elemental sulfur, ammonium sulfate, thiosulfate, gypsum, and then some sort of potassium sulfate or potassium mag sulfate. Okay. So starting with elemental sulfur, it's a granular, insoluble form of sulfur. It's literally 100% sulfur. It's the cheapest source. If we want it in terms of like on a per pound basis, but it requires conversion. So it requires oxidizing microbes to take that and convert that into sulfate and make that available. Like all things microbially related, oxidation is going to depend on soil temps, moisture, aeration, and pH. Okay. So elemental sulfur is actually a acidifying. It's quite acidifying. Here's the reaction: 2 sulfurs, 3 oxygens, and water, and then we get sulfate and this 4H plus, and that is a lot of acid, right? And so this is one of these forms of sulfur, or sulfurs. This form of sulfur is particularly acidifying, so that's something to consider when we're thinking about management. Now, we need 7.2 pounds of calcium carbonate to neutralize a single pound of elemental sulfur. Okay, so this is used actually quite commonly if we're trying to consciously acidify soil. Elemental sulfur is about one of the easiest and best bets to do that, and certainly safest and easiest application. So people that are potentially trying to drop their pH might apply elemental sulfur. It can become quite pricey in a hurry, so we have to understand that that's in limited applications that's available, at least economically available. So when we apply elemental sulfur, we're typically not going to expect that to be available the first year. What we'd want to do is apply it maybe in the fall or the spring, and then think about that being available sometime later in the year or even into next year. So if a soil is deficient in sulfur, we're going to incorporate it. Use it like lime. And sometimes it's quite common to use some sort of more readily available sulfate fertilizer that might be a little bit more expensive, and then including the elemental too is kind of take that fast release or readily available sulfur and then include some slow release sulfur as well. Okay, so that would be a general philosophy or practice. Ammonium sulfate, sometimes referred to as AMS. We talked about this in the nitrogen section, but this is a important source of sulfur. It's really kind of the choice when we're thinking about wanting both nitrogen and sulfur as a fertilizer source. It's a dry granular, 21% nitrogen, around 24% sulfur typically. Commonly used as a banded starter fertilizer. So we see this most common in Ohio practice, and it's relatively common for people to band this as a 2x2 and when they're planting, and you'll get both nitrogen and sulfur immediately. So both sources, this ammonium and the sulfate, are both immediately plant available. There's also thiosulfates. These are sulfur sources that are liquid fertilizer. So for applying sulfur, either as a pop-up or as a 2x2, as a liquid fertilizer, it's typically going to be in this thiosulfate form. So it often may contain ammonium, potassium, calcium, or magnesium. Here are the common names. You'll hear ATS, KTS, and then other forms with calcium and magnesium. And again, it's this thiosulfate with the respective other cation, ammonium, potassium, calcium, or magnesium. Here's the nutrient content. These are typically a higher value fertilizer. I mean, it's still used quite commonly in field crops, but usually at typically relatively low rates, so just maybe a few gallons of this. So again, a starter typically in field crop scenario, more as a starter application. If we're fertigating or irrigating, we can put this through drip irrigation or other center pivot or what have you, and think about it from that perspective. You have to be careful with this stuff because if we have to be very careful about salt index, especially if we're applying it in close proximity with the seed. But we commonly see people run into trouble because they're using thiosulfate as a pop-up. That is, they're planting seed and they're dribbling or spraying or incorporating that liquid fertilizer in direct contact with the seed, and we could get seed burn and very marginal seed emergence because of this. This is something that happens quite commonly, unfortunately. Okay, there's gypsum. Gypsum is calcium sulfate. Again, we've got this cation with sulfate. Very rarely available forms of both calcium and sulfur, about 20% calcium, 16% sulfur. This is dry, granular. It can come in a number of different ways. People often will apply gypsum as a calcium source, and because of that, they mistaken or lump it together with limestone. Gypsum is a neutral salt, so it actually doesn't change pH. This is a very common misconception that you apply gypsum and you get increases your pH just like lime would. That's not the case. Gypsum can either be mined as a mineral or it can be manufactured. If it's manufactured, it's typically coming from this FGD source, flue gas desulfurization. That's the product. We talked last time about Clean Air Act and these coal-fired power plants reducing sulfur emissions. That's primarily because they have installed, retrofitted the existing plants with these sulfur scrubbing technologies, and that's often captured with calcium. So, because that's a cheap source of cation, and so these manufacturing plants, you go along the Ohio River, for example, and there's coal burning power plants, and they have huge stacks of this FGD. Okay, it's essentially a waste product for them, but they put it in. It's really the same thing. It's calcium sulfate. They put it in gypsum board. They will sell it as fertilizer sources, and so this is, in Ohio, we've got a few different companies that essentially kind of promote this as a beneficial reuse product, Gypsoil being one of those companies. And so there's, various ways that we can actually get gypsum. And if we're thinking about OMRI certification, it's got to, organic certification, it's got to be this mine product. You're not able to use this FGD, not surprisingly, for that organic certification, okay? So then there's a whole suite of other sulfur sources that are out there, not surprisingly, crop residues, manures, et cetera, sulfur, we've been around this with N and with phosphorus, and even with potassium, but sulfur concentration, not surprisingly, varies by the type of livestock that's producing that manure, if that manure is in the liquid or solid phase, how much total is in that manure versus how much is going to be maybe available that first year. General rule of thumb is about half of the sulfur manure is available that first year, okay? So that's, there's a lot more that could be said about this. But typically when we find soils that are manured, are receiving manure either regularly or semi-regularly, we are very, very skeptical that we're very hard to believe that we're ever going to see a sulfur deficiency in fields that are receiving manure. Okay. Let's talk about, wrap up with recent concerns with sulfur and sulfur deficiency. I alluded to this in the sulfur cycling section, but there's been, if you look at trade magazines or just in general, look at what products people are trying to sell or pushing, there's a lot of concern about sulfur, or do we need to fertilize with sulfur, and think about that as a kind of a new fertilizer source that we have to purchase. Okay, so the justification is a number of reasons. So we have increased crop yields. When we have increased crop yields over the last few decades, we're going to get increased rates of sulfur removal. That's just kind of a known thing. The more we yield, the more sulfur our removal rates will be. Our use of sulfur-containing fertilizers has decreased. We used to use things like triple superphosphate or single superphosphate, and over the last, those actually contain sulfur, and those have, decreased over the years. And because of that, we're essentially applying less incidental sulfur in our fertilizer sources that typically were wrapped up into our phosphorus fertilizer that we would apply. Okay, the declining sulfur emissions, so essentially our free sulfur fertilizer from atmospheric deposition, quote unquote free, has declined over the last years. We talked about that last class with the last lecture with the National Atmospheric Deposition Program. And then there's fewer sulfur-containing pesticides. So these are all kind of reasons that we could also add to this, for example, fewer cropland acres that are actually receiving manure. So there's a number of reasons that we might be suspicious that our crops are sulfur deficient. Okay. I was involved in a project and thinking about, the various ways that how we actually assess sulfur deficiency. So we can actually often use leaf tissue analysis to observe a deficiency, but it's often too late to fix for that given season. So that's it can be a diagnostic tool, but when we get into tissue testing, it's always, is it too late to fix it, right? So we would ideally like a soil test that would tell us if we need sulfur to begin with. I'll just say this is going to be relatively brief. Actually very brief for the amount of time I could spend on it. There's been a lot of work trying to figure out how to develop a good soil test for sulfur. And the best tests are unsatisfying and the worst tests are very bad at it, okay? So what does that mean? Well, that means that just like nitrogen, sulfur can be very ephemeral. It can, over the course of a few days, can change depending on crop uptake and losses, etc. And we don't have very good diagnostics to say, if your, say, sulfur level is above 10 part per million or below 15 or what have you, you're going to need it over the course of the growing season. And that is one of the reasons for that is, with nitrogen, it was a lot to do with losses. Losses are large. Sulfur losses aren't as big, but we still need mineralization to occur, and that's a biological process. So suffice it to say that we do not have good sulfur tests to tell us when we actually need to apply or not, okay? And so because of this, some of the justification that we need to develop some other tools, other methodologies to actually use as a sulfur model, okay? So there's a new tool that I've been a part of, it was an Ohio State-led initiative, and that researcher went to Central State University, so he's still in Ohio. Shakti is still in Ohio, but I'll just demonstrate this a little bit just to give you kind of a taste of what we're dealing with. It's an online tool that needs to load. It's not particularly that fast. Again, this is in beta form, but it's similar to the P index. Hopefully, it works better for us than the beta P index did. And the idea is that you're going to go in and you're going to pick a field. Again, this is a Google Map implementation, so wherever we want to go, we can go through and we can draw a map. We can click to draw your farm. We're going to draw a polygon here. We can do something like this and double click to form the polygon. And then we can compute field statistics from this. Now what's happening at this given time, it's pulling data from a number of different sources. It's pulling it from a Surgo source, which is our soil database. It's pulling it for temperature and precipitation data, and then it's giving us some estimate of deficiency. Okay, so we've got these kind of fields here. We can click to export all this information, say in a PDF, but it's saying field number 1, it's been labeled as field 1. How many highly deficient acres are there? Moderately deficient, variable deficient. And this is kind of a best guess based on the organic matter, the type of soil it is. The organic matter, again, we're going to look at total sulfur in that soil. That's pulling it from a national database. It's looking at precip and weather data, so we can get rates of mineralization. And then we can actually specify with some of this, like what type of crop are we trying to grow? Are we growing, for example, a low sulfur requirement crop or a high sulfur requirement crop? And we click on some of these layers, and that can populate. We can also go through here and we can say, for example, download the PDF. That pops out, and I'll just take a look at that before we move on here. And so this is, well, let's go back. We can get a map with that. I believe we can. Let's export the tool. We can say advanced options, map only. Call it whatever we want. Map field number 1. So this is a tool that's in development, and like a lot of tools, it probably needs some refinement. We want to continue to build with this, but again, we can look at some of our statistics. We can download it as a PDF or as an Excel file. Here, this is, I don't know, it's taking a little bit of time to populate, but that's the nature of the beast. But it's going to spit out a map with a PDF with these kind of statistics. So, free online tool, here it is. We can just take a look real quick. Here's our map again, and then these are, the color-coded between moderately and variably deficient for sulfur, and that lines up with moderately and variably deficient, okay? And here's the definition of what this means. Crop response to fertilization is most likely, will usually occur, is likely, unlikely, or unlikely under any circumstance. So these are the types of questions that we're, types of kind of different approaches that we're doing to look at how we can provide tools for growers to think about sulfur deficiency and just kind of track that in their fields. Okay. With that, I will move back to my lecture, and I'm going to talk. So using this tool was one piece in trying to develop this, but then of course it's all based on kind of theory, rates of mineralization, crop uptake. We want to actually go out and test this and validate this in some ways. And so I want to just kind of show you a little bit of data. This is all field crop data, but we've had a very difficult time finding responses when we do apply sulfur fertilization. To fertilize sulfur and then look to see in a strip trial, these are all randomized and replicated, kind of the gold standard. can we find what's our likelihood of sulfur response? Okay, I'm going to blow through this because you don't need me to bore you with details, but Grace Block out of Laura Lindsay's lab, the soybean agronomist, ran 16 field trials, 9 in 2013 and 7 in 2014 in the following shaded counties. This was all soybeans. She applied gypsum, this calcium sulfate, at 2 tons per acre, which is a very, very large rate from a sulfur perspective. It's several hundred pounds of sulfur, and uptake rates might be 5 or 10 pounds at the most, right? So, no responses that they saw with sulfur. This data, all this was published in an agronomy journal manuscript several years ago. And we're kind of in the process now of trying to summarize and wrap up some of this. And so this is still a work in progress, but we're essentially wanting to put out kind of like a fact sheet bulletin in terms of all the work that we've done evaluating gypsum. Okay. So interestingly, on OSU farms, Clark County, Wayne County, and Wood County, we did see a small increase with gypsum fertilization at one site in 2015. That was not repeated in 2016. This is in corn. And interestingly, in 2015, we saw, again, a small marginal increase in soybeans that year. Okay, so this was clearly a site for 2015 that was slightly deficient. This is up near Bowling Green. Okay, no difference in that next year. We ran a lot of strip trials from 2017 and 2018, and these are the respective counties on the top. The site numbers. I realize that this is not, not very much to go from, or not a lot to see. It's a lot kind of jammed in here. What we see is the check treatment, the unfertilized treatment. I should have said this before. My apologies for this. Fertilized treatment is the dark, and then the unfertilized treatment, the check treatment or the control, is this light gray. So with that in mind, we can go back and look at the corn trials again. Gypsum versus the control or the check, and for the OSU farms, there was one out of 6 years, that 6 site years, that we saw a difference. For soybeans, the same. Going to these large on-farm trials in corn, we can see instances, for example, Darke County here, where we saw reductions in fertilizer. Again, this was, we suspect, from too much. This was applied as a starter fertilizer and saw reductions. But we did see increases in some places. But all these other panels, different counties, different years, or different farms, they, when there's nothing listed, there was essentially no significant differences. Okay. Again, that was corn trials before. This is soybean trials, and we had significant reduction, say here in Logan County, but a significant increase in Wood County. Okay, so what this means is that we, this is not all the data that we have. I just showed you some of the data that I was part of collecting, and then we've got other data and other various projects. What this means essentially is that we've got about 100 different experiments we've run in the last, say, 5 years, 6 years. We've got a total of 3 yield increases in corn and 2 yield increases in soybean out of about 100 experiments. Mostly, a vast majority of those were in corn and soybean. So, not a very good probability of seeing a response. Certainly we don't feel after this that we have widespread sulfur deficiency that everyone needs to start fertilizing for. But despite what you read, you might get that impression. That's certainly not what our data are showing. And I would argue that we've got a lot of data compared to what most people have that are out there selling sulfur products. Okay, so we have very poor tools to monitor sulfur deficiency, so it's very kind of difficult for us to provide great recommendations in terms of how to manage this. The best way to do it, it's time intensive, but go out and apply a strip of fertilizer and then on one section and don't apply fertilizer in the other, and take a look and see if you see any noticeable differences with the crop. That's unfortunately, a good way to do that. It's kind of really the gold standard. In the meantime, we can point to some of the tools that I showed you, like that the Sulfur online Sulfur Google Map overlay tool. But that's helps get us in the right ballpark. But it's not going to be a definitive yes or no. Do you need it or do you not need it? So I'm very. I do not believe that we're going to be able to find a very good. We're not going to develop a great sulfur testing tool. Malic 3 sulfur is typically how sulfur is evaluated, but if you've got we've got Malic 3 sulfurs that are, and I didn't show you these data, but sulfur levels that are 8, 5 part per million, and we didn't see a sulfur response when we fertilized. And we've got Malic 3 sulfur that's 20, 22 part per million, and we still saw a sulfur response. So unlike phosphorus, unlike potassium, soil test sulfur is not a good diagnostic method. And that's an important take-home, really, to kind of understand that when we're dealing with sulfur, just looking at Malic 3 sulfur is not a great way to manage it. I'll end there, and we'll pick up with calcium and magnesium next time.